thank you very much for joining today. And what we're going to be doing is we're going to go through the onboarding of our project, the High Altitude Balloon Mission with NASA. So there's a very short agenda. We're going to go through the mission parameters and have a look at the payloads, dates and deadlines, as well as the next steps. So I think we've all seen this photograph before of this test module that Bianca had built, just, also to demonstrate how everything was going to be stacked. And so what it comprises 8 payloads. We have got number 6. The number 6 spot is still available. We were hoping it was going to be taken up by Northern Caribbean University, courtesy of Claire Nelson and Futures Forum. However, they haven't confirmed yet. So I think what we're probably going to do is move on. The number 7 was reserved. Bianca had actually reserved it for us. Mike from Princeton has requested if they could have another payload space, so they could get one of those, either 6 or 7. So they'll have 2 payloads that they're going to provide. So the payloads essentially are the extended core, the standard X chips. If you'd like to use the prototype boards, please, no wires. If you're going to solder it onto the boards, etc., but please, no loose wires. And the data needs to be written and saved to the SD card. There's going to be no communication downlink from the payloads. So MaxIQ is going to provide power. We've arranged the launch, and we're also going to arrange payload return. So at this point, Bianca, do you want me to hand over to you so you can just share with Jim and a little bit of a catch up for William on where you are so far, especially in terms of that enclosure you've been working on in the last week?
Yeah, let me do that. So I'm gonna do it like this thing here. So the enclosure looks like this. So there is now a strip here for remove before flights, and it had to just use a jack block because that have all the functionality for remove before flights, and it's then in a number of parts. So the bottom part, the base here, holds the top part here. So there's like 6 screw holes on both sides. There are machine screws in 3s, and then when they're not screwed together, then you can of course take the whole thing apart like that. The inside here, inside the this cavity here, is held in place by 4 screws here on each side that holds into these screws here. So they're in 2. They hold the thing into space to the right place on this thing here. The reason why we have this space available is because I decided to have the battery turning outside, because we have the more space when we fly. We might as well use that, and therefore there is a little bit bigger roof on this thing here, because in between here is going to be another plate that screws into these holes that sits underneath here, and that will insulate the battery chamber, so the batteries are inside. They're also going to be heated, so there's going to be I think 5-6 watts of heat that can be dissipated inside, that controls. So there's a temperature sensor that will turn on and off a high power resistor that will work as a heating element inside here. And then this is of course polystyrene, so that is naturally a heating element. And the cavity, there is a 1 centimeter insulation layer all the way around, which is have honeycomb stats inside that kind of like traps the air. So that all works as insulation. Each of these layers, there's a layer on the bottom, which is the control layer. And then, of course, there's a layer on the top, which is the battery power layer. And the charging of the batteries is probably also going to happen through this port that is used for remove before flight. So the same plug like that can go in and can then charge the batteries. I'm still working on that part. So, so I still have to confirm that I can actually do that. So if there's a need for charging on site, it should be charged that way. So there's no reason to have to take it apart. And the reason for that, Tim, is that for these kind of flights, it will be installed. This thing here is plugged in and is galvanic in isolating the batteries from anything. So there's no like a trip or drain from the battery of any sort. When this is in, it's completely like they're lying in a box. So of course, just before flight, this is going to be removed, and then the whole thing is booting up. So the control layer here have very little functionality on this flight. What I hope to do is that I might have some special chips on board, such as a RTC clock, and then I can communicate that signal to the other boards, so I can tell what the time is if people want to have the accurate time. There's no reason that we have an RTC clock on each layer. Obviously, we can if that becomes important. The other thing is that depending on how much time I have, I might do some software. So I will do a library. My idea is that's a library where when you start up, you call immediately in your setup, and you are doing a setup, you will call a library. So you get powered up. Each of the boards get powered up individually. So this control board here can control who have power. So the way it works is that on the end piece, which I'm now taking off so you can see it, on the end piece here, each of these are 3.3 volt power supplies, LDOs, that give 350 milliamps to each layer. And this is a I2C expander, so I can control that. And then there's an enable pin on these things, I can actually turn power on and off to each layer. And the reason for that is, of course, to make sure that nobody's kind of like screwing up the mission. So if any layers are like suddenly go wild, or there's a, you know, if somebody has prototyped the board and there's a loose connection and suddenly it seems to shorten and things like that, then it's not going to affect any of the other ones. The other controller, there's one in both ends. The other one is for the CAN bus. So I can also control whether you can talk on the CAN bus or not. That was done by actually sending a signal. So here's the extended board. So you send a signal over that, and it enables the CAN transceiver here. So I go in here and control that. So that way I can control who can talk. And all that is just to make it easier, because I can then turn on and off the CAN, so I can kind of like broadcast and say, who are you? And then I turn off everybody. So when they talk back, I know only one talk and who it is, and I can then control that. All that is gonna just be a very simple library calls, so like 4 lines of code or something like that, where you have to do an include statement, you have to instantiate this library, and then you call a function in the beginning of your setup. And if you then want, my idea is that at the end of your setup, you can call it again and tell the status. So if you, for example, want to have a status signal from which of your sensors are working or not working, then you fill in like a string, and that string I then get. And then my idea is that when you are there, you can actually then Wi-Fi connect to this thing here. And then via the Wi-Fi connection, we can then see which payload is working and not working. So it's a way to kind of like assemble the whole upfront and then check that it works before we launch it, or at least know what's wrong, if anything was wrong before we launch it. So each layer, so this board here, I'm getting a new one on Friday. It's actually being shipped right now. So it looks slightly different. There's no connector. This middle connector here was something I was considering in order to put solar panels on, but we're not having any mission in the near future where that's needed, so I'm not gonna have that on. Otherwise, it more or less looks the same. There's no numbers here because they're just confusing, because this is the same on both sides. So I'm only producing, one PCB, but I'm using it both sides because I can just turn them upside down and then it works the same. And then of course the numbers is then 0 on one side, 7 on the other. So I dropped that. Then another thing that's happening is that a new battery module. So this thing here, I removed the one battery because otherwise it runs. So the battery module is being changed. So right now there is these 4 batteries. I'm not sure if I'm gonna use 4 or 3 batteries in my final design. I'm actually busy with it right now. I've done a test PCB for the whole heating thing, so I'm gonna test that using our deep freezer to kind of like figure out if indeed I'm right about my assumptions. It runs a 4S configuration. That means these batteries are in 0, so they're like 14.4 volts. And the reason for that is that then I can keep the PCB traces on the board, down. I don't have to be nervous about that. I have to send all the power over like white traces. So I actually sending 14.4 volts down the board here. And of course, each of these LDOs is then down regulating it down to 3.3 volts. So one gets what one's need anyhow. But the outside bus and the charging, the idea is to use USB-C PD, so power distribution from USB-C that goes up to 24 volts or something like that. Just if I was continue down that line, or I might, as I said, using the phone jack here to actually charge it. So I'm still working on those 2 options. The idea is to have an external charging circuit instead of having charging circuit on that. So I'm just connecting the charging circuit, and using this connector, I can disconnect the batteries so they're not part of the rest. So that way it's like I can isolate the 2. The payload itself, I have a little demo payload here. So obviously, let me see if I should hold it like that. So obviously you have the extended core, and on that you have your SD card. So make sure you have the SD card working and all that kind of stuff. There is room for this port here because you're not using it. So hang on a second. So there is this prototype board. So you can actually prototype by using a board like this thing here. There's 2 different prototype boards. There's also a very simple prototype board where you can use LTC if you want your students to kind of like solder something together. Then there's a board that just requires 2 resistors and 2 LTC resistors, and you will use that board that Judy holds up there. So that's the 2 different boards there that are. So you can simply just plug that in to your board, like I'm doing here, and then you have a prototype board. And that board runs, there's 2 I/O pins you can use. There's SPI, so if you have anything that runs SPI, you can run it, and it's I2C on this. Then you have, of course, your standard components. I'll turn around again here. You have your standard component, whatever components you have. And then this is a light sensor. And there's a 3D model here that makes sure that you can actually see the light sensor from the side, since that is a window you have. You don't have a window that goes straight up. So if you want to see some light on the upper side of it, you can do it that way. Obviously, the light comes in anyhow, so it's not like a super must, but there's a 3D model. This version I have here is a little bit too high. I have to make a shorter one. And I used some small mirrors that was pre-cut. I bought at Amazon. I think it's like for some craft mosaic or something like that. So you get some small mirrors there. So you can see that is the same. Where are we here? That's the same as the light sensor that I have. Not on my board anyhow. So there we have the light sensor. Then there's another prototype board here for I2C. And yeah, that's a light sensor. You can see here, Judy, just hold it up again. You can see that should be more or less the same. There's a little bit of tape on mine here to hold the mirror in. Obviously, it should be rather glued, but for now, yeah, that's good, thanks. Then there's a prototype board here, and it's not, yeah, that's a green prototype board that Judy have. I also have one here. So that prototype board, if you, for example, have like a Adafruit or SparkFun sensor you would like to fly, then you could put in. Of course, you have access to I2C, and you have access to serial port here. It just complicates things if you use the serial port because you have to plug it in and out when you program. But you have, and you have one I/O pin you could also use if you need to here. But the idea here is to use I2C. And then you have your own sensor and solder it in. There's a little piece of wire here. So as I said to Judy, we can't have wire hanging around. So you can't do like a prototype like this is the before example here where I just put two LEDs on and all this wire here is just gonna confuse it. But obviously when you solder the prototype board together here and you configure it, you have a few wires here you configure. So that's, you know, pretty all right. Of course, yeah, so that's the payload, and you can choose however you want to fill it in. But then you, of course, have to program it. And I'm very happy to be on a call and assist if there's any issues with programming or figuring out. All the pins for all this thing here, both this one that's sticking on the other way, is available on the GitHub. So if you just, yeah, actually, if you go to domino4.com, it automatically goes to that GitHub page. So domino4.com to go to the GitHub page. And there you will find the CWV, which is the extended course that will explain all the pins there. But there's like some repository pinned at the top. One is called technicals. And you will also be able to see some more information about the pins that are used if you want to do something special. But as I said, schedule a call if there's something. Once this whole thing is assembled, then this thing here, the base is being screwed in to the bottom of the gondola. There's a floor, and it's been screwed in with 8 wooden screws. They're countersink, so you know they don't stick out or anything like that. And of course, if NASA prefers it, we can also just mount them knock and bolts, you know, underneath the floor. But because we know it's plywood, I assume that's fine. I have tested this thing here in a configuration where I put it together like this, where it hangs this way here on the side, like exactly as I hold it. And I put 4 kilo on top here. Oops, after I was screwed together, so I put 4 kilo here, and then it hangs like a day to see that it didn't break. And this is just normal PLA. I might print it out in carbon fiber and forced nylon for the final flights and for the final assembly. This still here is undergoing a few modifications because this hole is probably going to move when I do a new version here. And I might put a LED or two in so one can see if it's working when it's assembled. So this is screwed into the bottom, and then the whole assembly, the whole version has then been screwed into this, and then the machine screws in and it's ready to go. Of course, have to pull out the remove before flights. So I think now it's a good time for questions. And everybody's on mute, so I just want to say that.
Okay, great. William, do you have questions? Jim, do you have any questions?
How big are those holes? Or what screws can you use to tack it onto the gondola?
Okay, so I sent the email to NASA. You were included in it also.
Yeah, I guess I didn't read it carefully.
Okay, that's fine. So the screws here are 5 millimeter in diameter. The countersink hole is 8 millimeter in diameter, and the thickness of once that goes in, of course, the entire thickness of this is 12 millimeter, so 12 millimeter, half inch, and the countersink part is 4.8 millimeter, something like that, leaving like 7.2 millimeter of holes. So that's the size of these. I made them kind of like rustic enough that we should be easily able to find. You can definitely just take an M5 or put through, or like M4 is probably more accurate, or 4.5, or whatever that is in equivalent in inches. So my idea is that if they're happy with wooden screws, I sent it to NASA here yesterday, so they can tell us what they want. They got the model also, the 3D model.
Yes.
So they can print it out and or analyze the base. So the base is separate because then let's call it the interface between our flights and the NASA. So this is our interface. So if they say this is the way we can screw it in, then we can always come with our stuff and plug it in afterwards. So yeah, 5 millimeter holes.
So we're going to ship them the screws too.
My idea is to ship 10 screws or something like that.
Okay.
So there's a little bag of screws. All the rest here is assembled, and then I'm probably gonna just add a little screwdriver kit just to make sure that we have the right screwdrivers for this thing here.
Yeah, because what we might want to do is screw the base on first.
Yes.
And then.
Yeah. So the whole idea is to screw that on. This thing here, even though it was just coming out, it will actually be screwed in with these 4 screws here. That sits snug inside. It doesn't move around, anything like that. But I'm just holding in place with these. These are M2 screws. So there's 4 M2 screws, and that's the side PCB here that's screwed on. It's actually not the new version that comes out here have 2 in each side. One instead of in the middle, it's 1 there and 1 up here. So it screws in with 8 M2 screws into this thing here. So that's 4 M2 screws, and that whole thing is screwed in with 6 M3 screws to this. And these holes that don't have it now, they will have a heat insert. So it will be machine screws, so it's easy to screw in and out several times. So, yeah.
Yeah, the reason why I sort of bring that up is from my experience last year, they're the ones that drilled the holes into the wood, into the gondola.
Yeah.
Everything else was kind of my responsibility.
Okay, that's fine. So in the email I sent to them, where I also had all the pictures and things like that,
Right.
I also specified the dimension of the holes. So So and they have the HTML file of this thing here, so they can analyze that as well. And they have the HTML file for both of the things, so they can see how it works.
Right.
Yeah, it's a very slick system. Thank you.
You're very welcome. Thank you.
Other than that, I'm all set. Looks good.
Cool.
Jim, do you have your hotel?
No, not yet. I don't even know what dates, so once I get that, I can start moving forward, figuring things out. You have suggestions?
So I stayed in Santa Rosa,
Okay.
and not where the flight actually will take place. There's another city, I forgot the name of it.
Mm-hmm.
Fort
Even though
Sumner.
it was Fort Sumner,
Fort-
yeah.
Fort Sumner, yes.
Yeah, and even though it's about 30, 40 minutes away, there's a few better places to stay
Mm-hmm.
in Santa Rosa. Uh, and I'll send you the hotel I stayed at. It's like a Best Western or something like that.
Okay, yeah, I think I saw that one on the list. Yeah, when I was looking.
Yeah. And you can walk to the restaurant or drive into town. But other than that, it's a straight shot from Santa Rosa
Excellent.
to Fort Sumner.
Thank you.
Jim, the date that they gave us last week was 12th of August.
Oh, okay. Let me write that down then.
August 12th. Yeah. Fort Sumner.
Okay. That's great, because now I can start planning better.
Fantastic. Thank you.
12.
And
And so that's the date of the launch, right?
plus or minus 4 or 5 days, or I should say, plus 3 or 4
Up
days.
yeah.
Yeah.
It won't be earlier than the 12th.
Right.
The planned
right.
date is the 12th, but it may slip to, let's say, the 13th or the 14th.
Yeah. So you
Okay.
might want to get there the 10th or the 11th. I think they gave us a schedule last time, Judy.
Yes, definitely closer to the time they gave us a schedule, yes.
Okay.
Yeah. And you'll fly in and out of Albuquerque.
Okay. Very good.
At least that's what I did.
Sounds good.
Yeah.
I got that loaded.
And if you're a history buff, you're on Route 66.
Oh, okay. That's great to know.
Or a music buff.
Well,
Quite a
Route
number of-
66
quite a-
was is like historical, but yes, there are
Yes.
songs about it.
There's a number of songs, yeah, about
Right.
Route 66, not only the Rolling Stones, but also, you know, with the Eagles song Hotel California, you know, it's you're getting to the end of Route 66, you know. So yeah. Great. So this is the plan. So when we got the date last week, what I did is that I then worked it backwards. And so yeah, communicating the plan, and we're having the onboarding workshop today, and then there's another one tomorrow, but later in the day, so it suits more people. And then the first workshop the week of May the 6th. So I've invited everybody to those 2 workshops, which is really actually workshop 1. And then I'm still to set up workshop 2 for the May the 20th. And then what we thought was building payload basically from this week through to June the 10th. That week, the payload should be complete that week of June the 10th, tested, locally at school, mainly to make sure that the data is writing to the SD card, etc. And then shipping all of the payloads to MaxIQ. So closer to that week of the June the 17th, then we'll kind of decide, where is everything going to be integrated. Jim, maybe what we do is maybe we actually just we send everything to you. Maybe we send everything to William just to coordinate that we have all the payloads. Maybe they send to Cape Town. I'm not sure. We do have 2 participating groups from the African continent, so those would probably come via Cape Town anyway. Yeah, and then we would need to do a final test of all those payloads. That's also why we're thinking perhaps they come past, maybe they all do come past Cape Town so that Bianca can do a really thorough final test, integrate them, get everything off to Jim. And then Jim, then you have everything, latest that week of the 22nd of July. So there's, there's some nice good time in between when you have it and when you need to travel. Because we also need to consider that it's ISS R&D. That is, I think that's the week before that launch, isn't it? Isn't that around?
Yeah, it's right around.
That's early August. Yes.
Yeah.
And and then what we did last year is once the payload was recovered, all the payloads were recovered, we sent a shipping label to the NASA team, and then they just shipped it back. They shipped it back to William, everything back to William. So we'll arrange that. We'll arrange that. You have your cat is doing that thing that cats do, where they have to be here.
Yeah, they do, all over me.
It's wonderful. So what we'll do is we'll make sure that you have got something for them to package it in, and with the shipping label.
Yeah.
So all they need to do is just drop it off at USPS, and then that's done.
Great.
Yeah, so that really is the plan. So the next steps from now is the invitations have gone out for the first workshop, but I think between now and then is to decide on which X chips to use, if one's going to do prototyping or not, and to actually start coding. Because taking Bianca up on his offer to have a workshop around the coding, let's see how much of that discussion we can have during that first workshop, because that's what's going to take the time, is the coding. The hardware is going to be the easy bit.
Yeah.
That's been done by Bianca over years. But the coding, that's what's going to take the time. So there we have it.
Very good.
Okay.
Sounds good. So what else is so like when you're saying workshop 1, workshop 2?
Yes.
Workshop 1, you might work in some code. What else do you plan for workshop 1?
It's really what it's going to be is it's going to be so people can ask questions, starting to work on it, and what questions do they have. So it's going to be it's going to be very much an open. They're going to be open sessions.
Very good.
Giving everyone an opportunity to chip in.
Yeah. Sounds good.